Hello, I am Kumar Dwivedi. I am here to discuss normalization. So normalization is basically breaking the relation into multiple relations unless we are not going to store the data on a single relation. So now the question is, why we need normalization? We need normalization because of certain anomalies, and these anomalies are insertion, deletion and updation anomalies. I am here to explain insertion, deletion and updation anomalies. So take an example of employee underscore department, where it has employee number, employee name, address, department number, department name and department manager number attributes are there. If suppose we wish to enter a department's information where there is no employee as such specified, in that case we can see that employee number is a primary key, and in that case we are not able to insert the department record because primary key cannot be null. So this is the insertion anomalies. Deletion anomaly is, suppose any department has only one employee and that employee has already left the department. So in that case we wish to delete his information. So if we delete his employee's information, in that case whole record will be deleted. Similarly, if any manager of any department has changed, in that case we have to update manager's information in all the rows. All the information of department manager's number should be updated. If any case we are not able to update all informations, then it will cause an error. So these are the anomalies. These anomalies are basically the reason of normalization, where we break a relation into multiple relations. So suppose, so first normal form, there are several types of normal forms. So I am here to discuss only 1NF, 2NF and 3NF. So in first normal form we basically maintain atomicity. So why atomicity is required? So in case of SQL, if data is not atomic, then this will increase the complexity. So atomicity is required, and this is the basic definition of relation itself. So there is an example of course and content. There is an example of a table where course and content attributes are there. So programming attribute, programming course correspondence contents are Java and C++, and corresponding to web attribute there are HTML, PHP and ASP. So there should be single information in the content table, content corresponding to programming, and there should be single information in corresponding to web. So in that case we apply first normal form, and the table will become programming Java, programming C++, web. So now we can see there is an atomic information available in every rows. So in second normal form, before second normal form we have to discuss prime attributes and non-prime attributes. Prime attributes are those attributes that are part of the candidate key, and non-prime attributes are those attributes that are not the part of any candidate key. So I have taken an example, student project. Before this I shall discuss what we do in second normal form. We basically maintain fully functional dependency and we remove partial dependency. So in student project example, student ID, project ID is the candidate key. Both must determine student name and project name by functional dependency, but we can see that student ID also determines student name and project ID also determines project name. In this case there is a partial dependency exists, so we break this relation into two relations. and the first relation is student ID, student name, project ID, and the second relation is project ID and project name. Now we can see student ID can determine student name and project ID, and project ID determines project name. Now in third normal form, we basically remove transitivity, but there is a condition. Transitivity should be exist like if any prime attributes determines any non-prime attribute, and non-prime attribute is further determining any non-prime attribute. This case of transitivity is removed in the case of 3NF. So there is 2 points. So no non-prime attribute is transitively dependent on prime key attribute, and for any non-trivial dependency X determines A, X should be a super key or A should be a prime attribute. Now there is an example of student detail. Student ID, student name, city and zip are the attributes. Here we can say that student ID is the primary key, and this primary key must determine student name, city and zip. But there is an attribute which is determining another attribute also, and this attribute is zip. This is determining city. Zip is also a non-prime attribute and city is also a non-prime attribute. In this case we are seeing there is a transitive dependency, that is student ID determining zip and zip determining city and student determining city. And in this case, first case we can see no non-prime attribute is transitively dependent on prime key attribute. So student ID is transitively determine city. So in this case we apply 3NF, and after 3NF we basically generate 2 relations. In first relation student ID, student name and zip code are there, and in second relation there will be zip code and city. That's all.